Est-ce que ça va des fesses Nantes? Ah, qu'est-ce que vous êtes beau. Eh bien, écoutez, on est là aujourd'hui pour continuer cette aventure du Defest Nantes. Une journée encore à tenir. Bon courage à vous. And now switch in English because Sara Vieira will be doing a talk in English. So Sara is from Avec. She's well known in the open source community, and she will be talking about Emulator in JavaScript. But she told me something this morning, and I was very laughing about it, because she did, how do you say it in English? She didn't have a flight 2 days ago. So you know why? She didn't bring his passport. So she was like, oh, this is the first time that happened to me. I don't know why. So she's here. We are very happy to have her. So please make some noise for Sara Vieira.
Bonjour, that's all my French. Sorry, I'm Portuguese. Hi again, my name's Sara. I forgot my passport to the airport, which is a problem because I live in London. That part should have been explained. So I could get into France, but I couldn't go back to London. And you're all like, well, God made this choice for you. So again, yeah, my name's Sara. I work at a company called Pilot. I'm a product engineer. But that's not really what I'm going to be talking about. I'm going to be talking about building an emulator in JavaScript, so absolutely nothing useful. And thank you for coming to the English talk. And if I'm speaking very fast, I don't know, just wave your arms or something. Yeah, I'm faster in Portuguese, so I don't know. I don't know if that helps. Cool. So this talk started as me sitting down and being like, I want to make a Game Boy emulator in JavaScript. And as you know, that went terribly. Turns out making emulators is really hard, which is something that I should have known before, but I was blissfully unaware. So I ended up scraping the Game Boy part because the sound just terrified me. But I still made an emulator in JavaScript. And I'm going to be showing you how I went through those steps, how painful it was, what are some things that are important to know if you want to go on this journey. And basically, nothing helpful for your day-to-day life. I'm betting a lot of people here are not JavaScript developers, and they're just like, she's going to make some cursed fucking shit. And I am here for it. And I am. That's exactly what I'm going to do. OK, I want to, two things. What I'm going to show you is definitely legal. The reason this is here is because I've always wanted something like this in a slide on a talk of mine. But also, I think there's a lot of misconception about what is legal and what is not when it comes to stuff like this. So emulation is technically legal. Technically. You know, like popcorn time? Does anyone remember popcorn time? Yeah, that was technically also legal. But like, OK, so emulation has been, I don't know about the how it happened in most of Europe, but I know how it happened in the US, how it became legal. Again, I'm not American, but we all are in a way. But basically, back in the 2000s, there was a company called Bleem. There was a company called Bleem who made a PS1 emulator. And they wanted to make it for Macs. And they went to Sony, and they were like, yo, can we have the BIOS? Can we have some of this information? Sony was like, what the fuck, no. So they decided to make it themselves. And they released the emulator, and there's a video of Steve Jobs being like, you can play PlayStation 1 games on a Mac. Back in the day, now you can't. That was the day you could play actual games on a Mac. But, I mean, I have a Mac, but I get to make this joke. But and Sony was like, you can't do that. So Sony sued them, and turns out what they did was completely legal because it was reverse engineering, which is protected by law in most places. So as long as you don't use any sort of proprietary code, emulation is completely legal. Having that said, I am not a lawyer, and do not fuck with Nintendo. Just literally anything else is fine. Just do not fuck with Nintendo. They will find you. They will open an office in France just to sue you. OK, so what is emulation? Who in here has used emulation devices, emulation things? Cool. So basically, there are two types of emulation. There is hardware emulation, which is not what we're going to be talking about, but I think it's really interesting. So there is, if I think it's interesting and I'm the one doing the talk, you all have to listen to me. So there's this thing called an FPGA, which is basically a chip that pretends to be the console you want it to be. So one of them, I think the most known one is the Analog Pocket, which pretends to basically be a Game Boy and stuff like that. And it's emulation, hardware emulation. So it's not software. So, and then there is software, which is what we're going to be talking about, and it's what I would say 99% of emulators are, like anything you know, like RetroArch and DuckStation and RetroArch. So all of those, including RetroArch, are all software emulation. And software emulation is basically you get all of this data, and your software is like, OK, now I have to pretend to be a Sega Genesis. Mega Drive. Which one was the European one that I had? It was Mega Drive. I'm going to pretend to be a Sega Mega Drive. I still think Genesis was a better name, and I think they won, by the way. But yeah. So it gets all of this code, it gets all of these instructions, and basically does what the Mega Drive would do. Right? So it's not at the hardware level, it's software pretending to be something else. Like when you install a VM, it's a very similar thing to that. So that's the difference between software and hardware emulation. OK, now you may be wondering, why did you do this in JavaScript? And my answer to that is why not? I don't have a good answer. My only answer is why not? I can. And it sounds cursed. And you shouldn't. I think JavaScript is probably one of the worst languages to build an emulator on. Except HTML. OK, so we're going to be building an emulator, chip 8 emulator. So chip 8 is basically, like, I don't think it's something that I had never heard of. It's a very old console from the 70s that basically is, right now, I think it's actually French. I may be saying bullshit, but I think it's actually French. But like, someone created it, and all of the information about it is online, like literally on Wikipedia. So you can go through it and understand what you're supposed to do as the emulator. So it's basically the first emulator you'll build if it's something that you would like to get into. So that's like, baby's first emulator is usually chip 8. So it's a very old console from the 70s. It's a fantasy console. Like, there's not actually a physical device. Something like Pico 8, if you've heard of that. OK, so if you think of a console, pretty much all of them have 4 components. I mean, more, but 4. Actually, probably just 4. Like, I don't know if you've seen, but the inside of a PS5 is basically empty. So you have your hardware, which means your microcontrollers, your CPUs, all of that. You have your screen, which may or may not be in the console. So, for example, on a Steam Deck, it's in the console. On a PS5, it's not. It's your TV. You have a keyboard or a gamepad, and you have sound. These are the main things that you need to actually have a functioning device that you can play games in, or that you can emulate Windows 95, if that's your thing. Or, I don't know, people do that. I've done that to play older games. It's too old, though. Yeah, so these are the main 4 things that you will need. Right? Like screen, hardware, keyboard, or gamepad, and sound. Sound, to me, was the most terrifying thing for some reason, because I looked at all of these, and sound, I've never worked with JavaScript, like web audio API, and I was like, this is going to be terrible. It wasn't that bad. I mean, it wasn't that bad, and you will see why, but yeah, it still terrifies me. OK, so let's start with the screen. So there's specifications for the screen when it comes to chip 8, and the screen is monochrome. It doesn't mean that it's black and white. It means that it only has 2 colors. So it can be gray and red if you want. I made it black and white because I'm basic, but you can make it any color you want. And the screen is also 64 by 32 pixels, which, to be honest, in today's, it's basically invisible to the human eye. Like, I don't think you fully understand how small 64 by 32 pixels is. So we're going to do a bunch of scaling. Like, I also have really bad eyesight. Like, when I was a kid, I used to wear glasses. And before that, I used to walk around the house with, like, this eye in the middle. Yes, it's a party trick that I pull. Doesn't get me any ladies. They actually all get really weirded out by it. It's fine. Like, I remember this, and I was, like, 3 or 2 or something. And my mom, as a good old Portuguese person, took me to the witch. And the witch told her to get me to the hospital. You should visit Portugal. It's a great place. Great place. I can say this because I'm Portuguese. OK, so how do you make a screen? Canvas, right? That does make sense. That's something that we use in JavaScript. Like, we've all used Canvas. The API is cumbersome, but we know that Canvas works. So if I go back again, okay, there we go. 64 by 32. Remember that number, it's important. Okay, so we create a new canvas. Oh, also I have like a little, I know. So we create a new canvas and export this class, blah, blah, blah. And basically after that, we create a display. And display is gonna be an array of 32 by 64 so that you have all of these actual pixels on the screen, if that makes sense. So every single one of these is gonna be basically 1 pixel. So we're gonna need some scale. So we attach some scale to it, attach the canvas, and create the context. And then we define the colors. So as I said, it's monochrome. So in my case, I decided, okay, I want the fill to be black, and I want the background to be white. Why did I write one and then put the other one in hex? I have no clue. No idea. This was probably happened during 2 different times of my life. And then we define the width and the height. So let's say that the scale is 2. In that case, it's going to multiply the columns by 2 and the rows by 2. So rows, so 32, wait, sorry, 32, 64. 32, 64, yeah, cool. Okay, so you have this, you have 32 pixels by 64 pixels, they're all on a grid. How do you actually show it? I mean, you literally go one by one. So you get a function called setPixels, and this function is called by the emulator afterwards, like by the CPU in itself, or by the instructions. And you get a pixel location, which is the x plus y in whatever columns it is, so times the columns, how many columns you have. So this is a static number, a constant, like we have a fucking word for it. And then you get basically, is this pixel already on? So the way that chip 8 works is like it's either on or off. So in my case, it's either black, which is the background, which is off, or it's white, which is the foreground, which is on. So basically in here, you check, is it on? And if it is, if the pixel is off, you turn it on, basically. And if it's on, you turn it off. And you return if the pixel is on, if you want to do anything with it. Doesn't really matter. The main point of this is that like you want to get this pixel, and you want to flip it. Because those are the only 2 colors, right? So, and now you may think, and which is what I thought, like, okay, let's say you want to make a Game Boy emulator. Do you have to do this? That would be fucking absurd. You do not. So basically, Game Boys and anything above this usually works in a very different way in which you have sprites. There are some emulators for Game Boys and Mega Drives and stuff like that, which actually have the sprite viewer, so you can open it up. You can open up a game, and you can see all of the sprites that the game actually has. So let's say that you're playing Mario, and no, not Mario, Sonic. Sega doesn't give a shit. So let's say you're playing Sonic, and you can see all of the sprites that that level is using. And what the emulator does is not actually draw each sprite, it gets it and puts it on the screen, which is much easier than actually setting a pixel. So if this is something you want to learn, please do not be terrified by this part. You do not have to set each pixel of Sonic. That would be terrifying. No, like there are sprites that you use and you basically put them on the screen. So it gets called and then you plop it. Cool, okay. So let's go to sound. The very simple thing about chip 8 is that it only has 1 sound. 1 beep, no pops, just beep. So it's kind of like the monochrome display, but for sound. It only makes 1 sound when it's told to, but it doesn't actually have different modulation or anything. So we still have to go through some of the steps of the web audio API, like creating an oscillator and all of that, but we don't have to like suffer that much. It's easier. Okay, so first thing, we get the audio context, which pretty much everything now has. We get an oscillator and we create this context. Cool. And then we create gain and set it to 1 and tell it the finish of it, basically. So this is what you do to connect everything together. This is all boilerplate for just getting started with a web audio API. Do you understand now why this terrified me? Thank you. I heard 1 person laugh. That's all I need. Now there's like 3. See? That's how it works. You gotta make everyone uncomfortable. So yeah, so this is all the boilerplate you need to basically get started with the web audio API. It's kind of like Canvas when you create the context 2D and all of that, right? And now how do you play this beep? So if I go back, you can see that we have basically connected everything and we created an audio context. Okay, that's cool. There's an audio context. How do I actually use it, right? Okay, so first thing we check is there not an oscillator? Okay, and what this means is If I continue, you can see that I'm creating a new oscillator for each time I make the beep, or the boop, I don't remember which one I called it. And if I stop it, so let's say there's a stop, there's a play and a stop, and the stop function basically kills off the oscillator. So it basically just sets it off to null. Could I have done the opposite and say if oscillator return null? Yes. Why did it not do that? I don't know. That sounded much better. So you create a new oscillator, and you set a value, and you basically set a frequency and a type, and you connect it, and you start it. So this is all boilerplate for basically saying, play me this sound in a type square, which means the sound goes like this. So it's pip, pip, that's it. Like there's no wee, nothing like that. Sounds like a Portuguese person talking. No, we are very aware we sound Slavic, by the way. We are aware of this. You cannot tell us this because we'll get mad, but we know, deep in our souls. Because we've heard like people speak and be like, oh, that's Portuguese. No, it was Czech. This happened to me 3 times. And I did not learn. And I was in the Czech Republic. Okay, so what is the meat of any, the meats and potatoes? The meat of any sort of console is the CPU, right? It's where you have all of the computation, is where pretty much everything happens. I mean, now it's a lot of the GPU, but at the time, back in the day, it was the CPU, right? So you have 4,096 memory locations, and all of them are 8-bit. Okay. So what does being 8-bit mean? It means that it only takes numbers up to 255, so 0 to 255. So if you play any games from that era, a lot of stuff ended at 255, and that's why. Like, it literally like doesn't count upper than that. So a lot of it is that. So when you get 16-bit, basically means you can do a lot more calculations, and games are just better because like not only is it supporting more graphics usually because it's gone up in a generation, for example, but also it allows for way more calculations that make things smoother, right? Like it's harder for things, okay, for example, the PlayStation 1 had this issue. I mean, it wasn't really an issue, I love it, but if you play any PlayStation 1 game, you can see that the textures kind of wobble a lot. Like it's just a thing of the PlayStation 1 that didn't exist in the N64. Because the N64 basically didn't have textures, but that's not the point. So the PlayStation 1, the textures kind of wobble a little bit, and that's because PlayStation 1 did not allow for float points. So like the texture is trying to like find the closest integer to whatever it is, and it keeps like going up and down. And that's why that happens. Now you know. This is not going to help you get girls either. Or boys, I don't care. Yeah, so it has 8-bit in terms of memory locations and 8-bit registers. It has 16 of them. These data registers are basically places where you can put data, let's say high score, for example, and you can retrieve that later. It doesn't get lost, right? So when you go from one level to the other, that thing stays there, and it knows how much you have had. Like without, like if you turn off the console, it's gone. But like for example, if you look at a Game Boy game, some of them had the little batteries, coin batteries. And that was to hold it for a longer time, right? But if you just wanted to hold it for the time you were playing, you didn't need stuff like that. So that's what these data registers usually are for. Sorry, that was a lot of talking, goddamn. I usually do live coding. Okay, so this is what I'm going to be showing you how to, this is what I made, basically. This is an image. I want to make it very clear. But it's basically a port of Arkanoid. So all of the games for the chip 8 that I've used and that are in the GitHub repo that I'll share later are all CC0, open source, like you can do whatever you want with them. They are written in assembly, so I cannot do whatever I want with them because I have no idea how to do anything with them. But yeah, good talk. Okay, so you get a ROM, and me as a baby dev emulator person, I assume that when you get the ROM, right, you get the code of the ROM, like you get the assembly, and I assumed that I was making an assembly interpreter, but no, that would be too easy. What you actually get is a shit ton of numbers, and you have to figure out what they do, and you've reached a point in JavaScript where TypeScript can't help you anymore. Like, you need to abandon all hope, because TypeScript is gone. It's to be like, it's an array of numbers, and you're like, thanks, mate. That helps me in no way. I still use TypeScript, but this is what you get, right? And you have to be like, okay, what does this mean? What the hell is this? So all of these things are different instructions that you need to do for whatever you're doing, like whatever emulator you're doing to actually work, right? So you put in a game. This is the same game, by the way, so it doesn't have that many instructions. So you can imagine how it would be to make a Game Boy emulator, and now imagine what it would be to make like a PS2 emulator. I don't know how anyone does it. Honestly, insane stuff. Okay, so something very important is, let's say, let me come back, and also notice, no number is bigger than 255. But this is still a lot for a very small computer, old computer to handle. So one thing that's heavily used is hexadecimal notation. So right now, we as a human species, in general, use decimal notation, which is from 0 to 9. Hexadecimal notation is from 0 to F, which is, you can think of it as 0 to 15. And when I was writing this talk, I was thinking like, okay, how the hell am I going to show hexadecimal notation? My partner looks at me and she's like, the colors, Sarah, the colors. The hex color. What do you think hex in hex color stands for? Hexadecimal. So let's look at a hex color and see how this would transform. If you do this, you will go out here with a party trick that will basically allow you to convert any hex color to an RGB. What will you do with it? Absolutely nothing. I mean, maybe in the future you can be like my partner and see the colors. Like she will look at an X color and just know what color it is. Maybe that's a Spanish thing. Maybe it's a Spanish thing. Okay, so color badass, of course. How do you even go around like trying to understand what this means? Okay, so first you need to divide it into nibbles. There's other words for it. I decided to call it nibbles because I saw that one first and I like it. So you get all of this and you can divide it into nibbles, which are pairs of 2. And then you can go around each pair of 2 and try to figure it out. So you know that 0 to 9, you know that 0 to F is 0 to 15, so you know B, basically, what does it stand for? It stands for 11. Wait, yes. Okay, so you have BA, and from the right, you know, okay, so A is 10, right? And B is basically 11 times 16 by 1. So it's this is very confusing, and I make it more confusing by explaining. And I don't know how to make it better. I've tried this, and I'm like, okay, so you have 10, and then you have 16, like 11 times 16, because it's not at the base of 10, it's a base of 16. And then you can continue, and it's going to be 16 power 2, power 3, whatever. So you get this, and exactly 11 times 16, and this gets you 186. That's your R. Then you can do the same thing for the A, which will be 13 times 16, 218. And then you do the same thing, and you get 85. So which means that this color actually stands for, in decimal, in our normal ass notation, 186, 218, 85, which is exactly the same color in RGB. So that's badass, which does not look very badass. Do not paint your room with this color. I'm sorry, we've been redoing the kitchen. All I see is colors. Yes, so now you can take this party trick home. I mean, you don't have to, by the way. Like, I'm not forcing, I'm not going to be there. So we have these instructions, we know how to use hexadecimal notation. What do? Well, now I have a clicker. We have to tell the computer what to do. And how do you do that? With an iframe of Wikipedia. So if you go to Wikipedia and check for chip 8, you can see all of the things, all of the opcodes, which are instructions. Opcodes are the same things as instructions, right? All of the opcodes that you basically need to implement for it to do what you want it to do. So, wait, since I'm here. No, sorry, German. I think I'm going to screw this up, and now I can. Wow, no one says. Okay, cool. No one cares. Oh, no. Okay. Oh, no. There we go. I fixed it. See? Command R. It's HTML. Okay, so you have all of these numbers and all of these opcodes, which, again, are just instructions. And you have to be like, OK, when I get this instruction, what do I do? Right? And if I scroll down, you can see that these are all of the instructions. And you have things in here like X and Y. And these are, think of it as functions, right? This will make more sense in a bit when I go into the rest of this. But it's basically, these are all the instructions you have that you have to do something about. Cool. So there's a lot of stuff. So again, PS4. Imagine. OK, now I have to click out. And then, yes. we tell the computer what to do. OK, so we basically need a function that runs 60 times per second, which is every frame. I mean, it can be 30. I mean, if your computer doesn't run on chip 8 at 60 times per second, please. Please. Yeah, that's bad. But you, not every time, sorry, 60 times per second, execute an instruction. OK, first thing you need to do is you increment where you are in the computer, in the instructions by 2. Because again, every instruction is 2 nibbles. So you execute it by 2, cool. And then you look at this, and you're like, OK, what the fuck is that? So, bitwise operators. Who in here has heard of bitwise operators? OK. OK, that's actually, OK, so if I say something wrong, please be quiet. It's the first time someone has actually raised their hand. Bitwise operators. Aren't they neat? I just think they're neat. They're not neat. OK, so you have a bunch of operators to basically help you handle hexadecimal notation. Or in this case, I'm doing it with binary, which is ones or zeros. So it's basically a lot of stuff to help you handle this kind of stuff. So let's say you have an end, and you say, OK, so this 0x, it basically tells the computer this is not like your average number. This is binary, or this is hexadecimal. So you have to put this before. If you just put 1, 1, it's just going to think it's 11, which does make sense. By default, it usually is 11. That's what you mean. But in this case, it's not. So let's say you have an end between 1, 1 and 1, 0. This basically means both of them have to be on for that bit to be on. And in this case, both of them are not on, so it's a 0. If it was 11 and 11, then it would be the same, right? It would be 11, like they would be on. You have an OR, which, I mean, do you know what I know? You know. You know. And you have an XOR, which basically means the opposite. So it's like you have 11 and you have 10, and you basically just remove it in this case. And there's a lot more of these that you can go and try to discover by yourself. These are the ones that are most heavily used on this one, but there's a lot more bitwise operators, and this shit gets real deep. Too deep. OK, so if we go about this in hexadecimal notation, you can see that if you have a hef and a 0, an F and a 0, then in this case, oh, I have the thing, yes. So these 3 are zeros, which means that if you put an end, only this F will stand. Does that make sense? I will literally not continue until I hear a sound. The sound can be no, but then I have to explain it again. And we'll go back. Exactly, that's what I thought. OK, so or, basically everything is F because literally any of them are not 0. I'm going to do the same thing again.
Yes, it makes sense.
Thank you. Good man. And again, this one is the opposite. So whatever is 0 gets turned backwards, and whatever is F gets turned into 0. I'm OK if this one doesn't make sense. It still doesn't make a lot of sense to me. Please, carry on. OK, so now that we know that, we have this opcode here, right? And we want to get the X of whatever it is. So if I went back to Wikipedia, you could see that a lot of them have X's and Y's, and this is how you get the X for it. And you get this. So you get the opcode, and you get and this, which means that you will only get this bit. Because it doesn't matter what the other one is, all of the other ones in here are zeros, which means they will just get ignored. Yes? Thank you. God, I need coffee. OK. OK, so you get this bit, basically, and then you shift it so that you get better access to it, basically. And then you switch on the opcode and this, which means it's the same thing, but for this one. So you want to check what is on that position. And then we can switch opcodes. So basically, you go here, and you want to get these 2. Cool. And you see, is it 9E? And if the opcode that you got ends in 9E and like passes through all of this, it basically tells you you have clicked a button on the keyboard. This case it uses, I know, it's fucking insane. I know. Give me a second. There you go. It tells you this key got pressed, and what is the key? It's the X on the register, right? The register is just an array. Cool. So other ones, for example, are the sound. I need some water. You have the sound timer, and basically, how do you check if you're supposed to play sound? Is the sound timer bigger than 0? So in this case, you just basically set the timer to whatever x is, and then you have other stuff like if you do 0, 0, E0, it basically means clear display. So you have to run through all of this and go through each one and see, okay, what the fuck does it actually expect me to do? And now, just for fun, fun for me, not for you, I want to show you all of the code of this, which is not scrolling for some reason, but I'll scroll by myself, I can do that. So this is the entire switch statement to run this. This was, yeah, and it still ends with a catch. It throws a new error if there's no opcode for that. Okay, so you made it this far. Actually, yeah. I think there's more people now than when I started. It's usually the opposite. Okay, so now I'm going to show you like what all of this work and all of this learning actually create. This is an image. I want to make it very clear that this is not, yeah. So it creates this, which is technically the emulator for chip 8, and it runs, and it works, and it makes beeps, makes one beep, but you can't hear it, which is fine. I did say no sound, that I didn't need sound. So that's it. That's all of the pain and all of the sleepless days. Nights, sorry. Okay, so if you want to install it for some godforsaken reason, you can. So just go on my name, which has 2 I's. It's very confusing. It's very Portuguese. /chippy, and you can install it. And all of the code is also on GitHub. It's linked there. You can have all of my slides, and that's my blue sky. I don't post that much, but I usually have photos of the cat. There's a cat. She exists, and there are photos of her on my blue sky, because she's great. Yeah, no, that's actually the last slide. Thank you so much for having me. So now I think I will take some questions, and then you can go for coffee.